This hour, we're going to talk about this question right here. So what is a programming language? Sounds like this kind of either it could be a very academic question or it could be a really practical question. But I think as kind of CS majors, this is something that's really important to discuss because you have all been doing programming in the past few years, and you will likely do programming in the future, whatever career path you go down. Even if you're not going to be a full-time software engineer, programming is going to be everywhere. So this is a very relevant question. So first of all, to do audience participation, I'll hand this sheet out to all the students. I want you to all write down the kind of programming languages that you're familiar with and like ones that I guess you would feel comfortable putting on your resume for jobs. And this is not like a contest or anything. You don't have to put your name. It's all anonymous. I just want to start tabulating them so that we could start having something concrete to talk about, because otherwise we're just talking in the abstract. Okay, so this is a good mix of general languages that people have written down. Good. So this is what people are pretty familiar with nowadays, right? So general purpose kind of programming languages in different settings. So we can use these as a basis for starting to talk about programming languages. So, if people ask what is a programming language, I guess the first thing that you would say, let's go down here. So the first part of what a programming language is, basically if you're learning in a school setting, an academic setting, it will just end here. So this part is going to have there are going to be 6 bullet points here. I will progressively reveal them throughout the lecture. So we're going to have 1, 2, 3, 4, 5, 6. So I'm going to argue that programming language is 6 things. The first thing that programming language is basically what you learn in school if you take a programming languages class. The first thing we're going to talk about is specification. So the formal definition of a programming language is really a spec. So if someone asks you what is a programming language, it's a document some person or some group of people wrote up. So I'm glad some people wrote scheme or common Lisp here. So actually, the first thing we're going to look at is scheme. So scheme is a language with a lot of parentheses. It's a language made in the 70s, and it's known to have a fairly simple, clean specification. This is called R5RS, the revised 5th version report on Scheme. There's some newer versions, but this is the most kind of common version of Scheme out there that people implement. So this is the Scheme committee, including some of the creators. So Guy Steele and where's Sussman? And Sussman. So some of the creators, and these are kind of the kind of senior people in the Scheme programming language community. This document is about 50 pages long, about 50 pages with appendix and with references and stuff. So really it's around 40 something pages. And this is Scheme. If someone asks you what is Scheme, this is Scheme. This is the specification for the programming language. You can read it. I read this a few nights ago. This is actually surprisingly readable. It's actually kind of cool if you want like programming languages. So it's extremely readable. I mean, it basically describes the language, the syntax, the semantics, how you write programs, what these programs mean, how you actually evaluate the language. Given an expression, what are the rules for evaluating it? So this is the first part of the document is an informal syntax, which in semantics, which is just an English description of what things are supposed to do. So most languages have a spec that's fairly, that's pretty informal. And then the cool thing about languages like Scheme and ones that are a bit more kind of developed but more formal is that there's actually what's called a formal syntax and semantics. So this is kind of written in kind of more formal notation, mathematical notation here. So this describes a lexer and the parser. And where are the evaluation rules? Yeah, so these are kind of evaluation. So here are the formal semantics. So for those of you who are into programming languages theory, this is kind of mathematical notation for how do you evaluate a Scheme program as a mathematical expression. And I won't go into the actual details, but basically you have these equations like this. You have these sorts of evaluation rules. And this really compact one page of equations. This page here and this page here. These are auxiliary functions. Basically, these 2 pages of mathematical equations. it's like 2, and then there's some extras. That is a formal definition of the scheme language. So the cool thing about this is that you can do proofs over it. You can actually verify properties and say like, oh, would this thing, would this feature ever terminate, or how fast does it run and such. And then you can also create automated systems that check scheme programs and such. So this is an example of a formal language spec. And then there's the informal spec is more readable, right? Obviously, if you wanted to read this, it's kind of abstruse and you have to really understand logic and stuff. So the informal spec is the one you probably want to read, and it's more informal. And then there's reference and stuff. So scheme is around 50 pages or so, several column, but it's around 50 pages or so. Let's move on to another language, everybody's favorite, C++. This is one of the latest drafts of the C++ spec. How many pages is this?
238.
2,000. Try 2,000. Is it 2,000? 700, 800, 900, 1,000. It's about 1,000. Let's say let's give it 1,000 without things. So this is, it's somewhat readable. If you like, if you enjoy pain, it's somewhat readable. So C++, if you've worked with it, is an enormously complex language, way more complex than Scheme, especially if you want to go into all the weird corner cases and stuff. So there's all these rules for validating different things and templates and all these different things. So the sense here is I'm just basically trying to say that different languages have different specs, right? This is the spec for C++. It's very long and there's all this stuff in it. And one indication is just how long the document is as a measure of how quote unquote complex the language is. So who makes these specifications? So you can imagine one person just, starting a language, and, any of you could just make your own programming language if you want. You just write a document, you just put it online, and you just hope people adopt it. But languages that are in common use, the specifications are usually written by some group or committee of people. So either a lot of languages have what's called open specifications or standards, and they have some committee that meets, and they have representatives from academia and from companies that meet every year and say like, how should we revise our language? What features should we add? What features should we remove, and such. So if you're studying kind of programming languages from a school in a school setting, that's pretty much it. That's pretty much what you do. You spend in programming language theory classes, you spend all of your time or most of your time on mostly the formal specifications, actually, not even the informal ones. You spend most of your time understanding these equations and how the programming languages work, and what properties are about it that you can prove and stuff. So that why am I not ending my lecture here, right? So that's pretty much it if you ask what a programming language is.